In this session, let us see very important question and quite confusing questions with respect to interview point of view. Okay, why in India voltages are multiples of 11, and why our operating frequency is 50 Hz, whereas in America it is 60 Hz. Or kind of why frequency should be from 40 Hz to 60 Hz only all over world power frequencies. And if I increase frequency of the power, okay, what are the advantages, what are the disadvantages? And kind of in mobile charger. In mobile charger, mobile charger can directly charge when the supply is AC or DC also, especially when you travel in trains. Okay, in trains DC supply only will be available, but how mobile charger is working and what are the advantage of increasing frequency or varying voltage levels and all, let us see. Okay, see here, multiples of 11. People somehow connect this multiples of 11 to what do you say, form factor. Form factor is 1.11. So means if something multiplied by 1.11 will give you 11 kV, okay, which is wrong. Basically, for example, if I have some advantage of form factor, okay, form factor is 1.11, I know, okay. So for example, if you have some advantage of 1.11, my question here is very simple. Why to multiply 1.11 or okay 1.1 by 10 only? If I multiply by 10, it will give you, for example, 10 multiplied by 1.1 will give you 11. If you multiply by 30, that will give you 33. Okay. Now, my point here is, why can't we multiply with 9? If we multiply with 9, 9 multiplied by 1.1, 9 is my lucky number. Okay. So, if I multiply with 9, result is going to be 9.9 kV. So, it's going to be 10 kV only. Frankly speaking, mathematically, all numbers are multiples of 1.1 only. Because 10 by 1.1 some number will come, 13 by 1.1 some number will come. So mathematically speaking, if you come out of integer things and if you come out of that 10 or 30, so everything is multiples of 1.1 only. If you include that, points also, dots also. But anyway, point here is, why in India it is multiples of 11 kV. Okay, so there is no advantage of 11 kV, there is no disadvantage of 9 kV. I'll tell you why. Okay, basically this electrification in India entered when we were under the Britishers' rule. Okay, so when we were under the Britishers' rule, they used to we used to dump insulators from the British guys only. Okay, so at that time means they designed insulators of 11 kV somehow. Okay, so for example, 11 kV 1 disc insulator disc, 33 kV 3 disc, 66 kV 6 disc. Okay, something like that. We developed the system. And actually this lecture is very much important, especially for interviews and all. Okay, so because for example, if I have some advantage on 11, why our national grid is working at 400 kV? Because as per that notation, 11 kV is multiples of 1.1, 33 is okay, 66 is okay, 220 is okay, but not 400. Okay, basically we developed 400 in independent India. Okay, forget about the United States of America, their national grid is 765 kV. 765 kV is also not multiples of 1.1 or 11. Okay, so you may ask me now, in that case, why to go ahead with 11? Can we change that 11 kV to 9 kV? Yes, we can change. But in order to change that, for example, my lucky number is 9 and present system is 11 kV. Okay, so can I change from 11 kV to 9 kV? Yes, we can change. But in order to do so, you have to show some disadvantage in 11 kV and you have to show some advantage in 9 kV. Okay, because if you want to change from 11 kV to 9 kV, already existing system is there, crores of rupees are there in the system. Okay, if you want to change from 11 kV to 9 kV, all the insulator desks and all the distribution system and all the distribution transformers and many things has to be changed. Okay, so definitely the moment you have crores of rupees investment, Okay, if you want to change from 11 kV, for example, if you want to increase to 20 kV, 11 kV should be disturbed, which involves huge amount of money, so we are not going to touch that. Okay, so Britishers started with 11 kV with their discs. Okay, so we are continuing the same, because let us continue the existing system. Okay, because there is no disadvantage of 11 and you cannot show any advantage with 20 kV. So point to be noted here is, because as I told you, as of now you may think of 11 kV means some nonsense connection, like into 1.1 form factor, and some guys say if sending end voltage is 11 kV, receiving end voltage can be 10 kV. Okay, in that case, if sending end voltage is 20 kV, receiving end voltage can be 19 kV, no? Okay, so frankly there is no link of form factor with 11 kV, but we have to go back to the history, because it involves huge crores and crores of rupees of investment. Okay, so we don't have any special attention towards 11 kV. They built it and we are maintaining it. Okay, second thing, 50 Hz frequency. Okay, so in USA frequency is 60 Hz. In India frequency is 50 Hz. Is there any great disadvantage in 50 Hz, or is it any great advantage in 60 Hz? No. Okay, so for example, in synchronous machines, basically alternators, all generators should be of synchronous machines. Motors can be of two types apart from lighting. Okay, lighting load will be there, motor load will be there. Now lighting load, anyway, kind of lamps and all, forget about it. Now main thing is going to be motors. In motors, induction motor will be there, synchronous motor will be there. Okay, so induction motor is going to play vital role because of least maintenance rotating machine and all. But anyway, point to be noted here is generator side. Generator side, induction generator, what do you say, percentage of power delivered by induction generator is going to be very less. So all generators, most of the generators should be synchronous generators, and forget about the loads. Okay, so point here is once, for example, if two alternators are connected in parallel, if one is operating at 50 Hz, another alternator should operate at 50 Hz. For example, in India, first alternator which we dumped from maybe Great Britain, okay, if it is operating at 50 Hz, for example, first alternator is operating at 50 Hz, second alternator, you thought of connecting second alternator in parallel with the first alternator, compulsorily this frequency also should be 50 Hz. Okay, for example, in Japan, what has happened? In Japan, kind of one place alternator they dumped from Britain, okay, and another place they dumped alternator from 60 Hz, America. Okay, so now they are having two national grids actually. One national grid operated 60 Hz, another national grid operated 50 Hz. It's going to be very tedious and difficult process. Okay, so point here is very simple. Why we decided upon 50 Hz? Okay, because first alternator started in India was 50 Hz. So all remaining alternators to be connected in parallel with that existing alternator should be 50 Hz. And there is no such a great advantage in 60 Hz. There is no disadvantage in 50 Hz. But if the frequency variation is very high, one advantage will come. For example, let us think of transformer. In transformer, what was the equation? V equal to root 2 pi f B max AC N. Okay, so in this, for given voltages are given, and given number of turns, okay, root 2 pi is anyway constant. Under that condition, for given flux density, because already we know that flux density is not a term to play with. So for given flux density, if I increase frequency, area of cross section of the core will be reduced. Okay, means that, for example, this is the area of cross section of the core. In the first case. Okay, black case. For example, if I increase frequency, what about the area of cross section of the core? It will be reduced. Okay, so for example, in the first case, what is length of copper pattern? Length of copper pattern is this much. For example, if I am the limb, what is the length of copper pattern? Perimeter of me is going to be length of copper pattern. Okay, so if you cut me here, that is going to be area of cross section of the core. So area of cross section of the core, around that perimeter of area of cross section of the core, or circumference is nothing but length of copper pattern. Okay, so if I think of, for example, if I increase frequency, If I increase frequency, means this area is reduced, so length of copper per turn is going to reduce. Okay, so what is the greatest advantage? Of course, at the end I will conclude everything. Okay, just chill. Now, see, if I increase frequency, okay, for given flux density, for given voltages, number of turns anyway given, forget about it. Now, if I increase frequency, area of cross section of core is reduced, so volume of core requirement reduce. Okay, so if volume of core requirement reduce, cost of core will be reduced. Okay, so and again, what is length of copper per turn is going to reduce, so volume of copper will be reduced. So if I increase frequency, size of the machine is going to reduce, cost of the machine is going to reduce. Okay, so maybe now you may think of, for example, if I have 50H transformer, maybe of some power transformer. Now power transformer should be very huge, power transformer will be there. Now rather than 50H, if I can develop 50 MHz, for example, okay, if I can develop 50 MHz, then automatically what will happen? My size of the machine will become so small, cost of the machine or price tag of the machine is going to be so reduced, such that my power transformer can be of this much size, you can keep it in your pocket and go. Okay, so point here is, why don't we think like, if we increase frequency, volume of the core requirement, volume of the copper requirement, cost of the machine, area occupied by the machine is going to reduce. But that like, we cannot work out. Because maybe now you may think, in India 50H, in America 60H. Okay, so compared to American alternator, Indian alternator cost will be more. Yes, cost will be more. But that variation will not be 50H to 60H. What is the difference? Small. Okay, now let us think of, rather than 50H or 60H, let us develop 50 MHz or 50 GHz, such that size of the machine will become so small, cost of the machine will become so small. Okay, can we do that? No, because all over world, what is the power frequency? Power frequency will vary from 40H to 60H only. Why not 40 MHz or 40 GHz? Because how to develop, basically we have to understand one thing, we are not dealing with signal, but we are dealing with power, huge power, gigawatts of power. Okay, so giga units of energy, gigawatts of power. So power is the main thing for us. For example, how to generate sinusoidal signal? Maybe analog guys may say like, let us use BJT or FET to develop sinusoid, or simply LC oscillator can develop sinusoid signal. Okay, but that is just signal. But for us, sinusoidal voltage should be developed by alternator. Okay, so sinusoidal voltage should be developed by alternator power. Okay, for example, let us think of alternator. This is stator. Okay, so let me have one conductor here, let me have another conductor here. Now let me have my poles, two pole machine. Maybe let us think of this, the N pole and S pole, it is rotating. Okay, so if pole is here, let me keep pole here. As of now, how much is the induced voltage? When pole is here, as of now, how much is the induced voltage here? 0. After 90 degrees, so my conductor will be exactly under the pole center, induced voltage here will be maximum. So 0 here, sit here, as of now 0 induced voltage, positive maximum, 0, negative maximum, 0. So logic here is, in order to get one cycle of induced voltage, one revolution, it has to rotate. Okay, mechanically it has to rotate. It is not a signal of analog electronics here. Okay, so point to be noted here is very simple. Power, bulk of power, crores of rupees. Okay, gigawatts of power, giga units of energy. So point here is, in order to produce induced voltage here, mechanically my rotor has to be rotated. Okay, so if I rotate the rotor one revolution, induced voltage will be one cycle. So in order to get 50 Hz, 50 cycles per second, I have to rotate 50 revolutions per second. Second is over, right? So what is second? Over. So in that, my rotor has to be rotated 50 times mechanically. Okay, now for example, if you think of, okay, let us reduce the size of the machine, price of the machine, cost of the machine. Okay, so in order to reduce this, if you are thinking of rotating this, 50,000 times per second. If you rotate this 50,000 times per second, automatically 50 kilohertz will come. Is it possible mechanically? No. So all over the world our frequency is 40 Hz to 60 Hz only. Okay, so because between 40 Hz to 60 Hz only, actually mechanically it is viable for us. Mechanically we can rotate the rotor. Okay, so the moment mechanical constraints are involved, okay, so we cannot develop 50 gigahertz or 50 megahertz in order to reduce the size of the machine. So conclusion is very simple. For example, in many of the, what do you say, syllabus, okay, they will write in the syllabus power transformer. Okay, so people feel that, like, power transformer in the sense distribution transformer is not there in the syllabus. They think, which is wrong, because they are saying power transformer means that it is not distribution power, but it means that power frequency operated transformer means that frequency is going to 40 Hz to 60 Hz operating transformer. In the sense, both power transformer and distribution transformer will come. Okay, so like point here is power transformer, if you find in any syllabus of any competitive exam or anywhere, it is not that distribution transformer is not there. It means that power frequency operated transformer. Now coming back to the last question. Okay, for example, if you think of mobile charger, okay, this is very important question. For example, if you think of mobile charger, okay, in mobile charger, what is the power is going to be very less. What is the voltage of 5 volts? How much capacity is there? Very less. So the moment, like, power handling capacity is going to be very less. Under that condition, our analog electronics can be used. If power handling bulk of power, huge amount of power, we have to manage a transformer, transmit, means that analog electronics will not come into picture. Okay, now once we discuss this, all dots will be connected. For example, normal mobile charger, how it should be ideally, like, 230 volt supply we are going to supply. So from that voltage, output voltage should be 5 volts roughly of DC. Okay, so in order to reduce the voltage, focus here all of you please. If we want to reduce the voltage from 230 or some significant amount of AC voltage to less voltage. Now that particular less voltage, if you give it to rectifier, it will give DC. So we can use that to charger. Okay, so for example, just a minute. Now for example, if you see, my mobile charger is like this. Okay, so this is going to be transformer. For example, input voltage is 230 volts AC. Okay, so if output voltage of the transformer is roughly very less voltage, maybe roughly 5 volts AC. Okay, so AC. Now if I give this to rectifier, output voltage will be roughly 5 volts DC. Now give this to mobile. Okay, so if you feel that, what is the problem? Let us see. For example, if you have this, okay, now for AC input it will work, but how is it working in DC input of electric trains in our traction? Okay, so while you are traveling in train, definitely you are going to keep your mobile charger. Okay, so under that condition, the moment it is going to be DC. For a DC, transformer will not work, it will be short circuit. Under that conditions, how you are able to utilize your mobile charger is very beautiful question. Okay, basically my mobile charger, it will not be like this. Rather than that, what we do is, okay, first for example, let us think of 230 volts AC. 230 AC, it will be given to transformer. Okay, directly they will convert that into, first we will give it to rectifier. Okay, so directly I will tell you the advantage, just wait. It will be high voltage DC, in the sense 230 volts roughly DC, 230 volts DC, and this we will give it to inverter. Okay, so this inverter output is going to be very high frequency AC, so high frequency AC. Okay, if you give very high frequency AC to transformer, roughly 5 volts, high frequency DC, high frequency high frequency AC. This will give it to rectifier such that you will get 5 volts DC. Okay, so in this how, why we are doing all this, let us see. For example, 230 volts AC directly convert by using rectifier, let us convert into DC, and that DC let us convert back into AC of very high frequency. So the moment it is very high frequency, size of the transformer is going to be reduced. Okay, so the moment size of the transformer, because frequency can be increased. Now you may think of, why don't we do the same with our machines? No, because mobile charger capacity is very less. So the moment capacity is very less, normal BJT FET can work. Okay, but when the bulk of power is more, we cannot do that. Okay, so power signal should be created by alternator only. Okay, so the moment high frequency AC, transformer size will be reduced, cost of the machine will be reduced, and that will be voltage will be reduced, and that will be given to the rectifier. Okay, so this is the case, such that cost of the machine is going to be reduced, because signal it is going to be, power handling capacity is going to be much less. For example, in this, if I give DC in your traction, the trains, okay, so if you give DC, if you give AC, after rectifier DC will come, AC DC will come, DC AC will not come, DC only will come. Okay, so if you supply to the rectifier DC, after rectification process, only DC will remain. So means even if you supply AC or DC, after rectifier this is going to be DC only. Okay, so remaining process will be continued. Okay, so what is the conclusion? What is the conclusion here? Very simple. Okay, the first one is going to be, there is no logic behind multiple of 1.1 or multiple of 11. Okay, so in India we started British guys started 11 kV, we continued the same. We don't want to disturb the system, because if you want to disturb the system, it involves cross surface. Okay, and our national grid is not multiples of 11, American national grid is not multiple of 11. Okay, so forget about it. Now second thing is frequency. Okay, so all over the world frequency will be from 40 Hz to 60 Hz. In between, our India is having 50 Hz. That too decided by them only, British guys only. First alternator, remaining all alternators to be connected in parallel should be a 50 Hz only. Okay, so there is no, of course, from Indian to American, the moment frequency is increased, there slight advantage will come, but that's not the main advantage. Okay, so, and that's it. And third thing is the moment power handling capacity is so small, under that condition we will utilize the skill of frequency is increased, size of the machine or cost of the machine is going to be reduced. We are going to utilize this concept only when power handling capacity is much less. Okay.